Hello learners, welcome to the next session in the quantum machine learning. So in this session we are going to discuss about what are the different kind of machine learning, and here we are going to give more focus about what is supervised learning. So you know that what is machine learning? It's a part of artificial intelligence focus on enabling computers to learn automatically. This machine learning involves building and training models that allow computers to identify patterns and predict outcomes. So machine learning is very important for all kind of applications, speech and image recognition, recommendation system, and medical diagnostic, natural language processing, everything is there. So this machine learning, you know, that divided into different kind of categories. Supervised learning, we are in supervised learning, as we are discussed in the last session, we need labels for this supervised learning. To discover a function that converts input data into appropriate labels, classification and regression are the frequent supervised learning task. In the classification, we have different kind of application is there, and for regression also we are having some of the prediction methods are there. So in the case of supervised machine learning, each input is paired with corrected output. The goal is to learn the mapping from the inputs to outputs and make predictions on the new unseen data. What is the best characteristics of supervised learning is requires labeled dataset. So each dataset which is required label, class label. The model is trained with the input-output pairs, best applications for classification, predicting categories, for regression, predicting continuous data. For predicting categories, we can go for email detection, whether the email is affected or not, and for predicting continuous values, house price prediction. So here in supervised learning, we're having many different types of algorithms there. The first one is linear regression, next logistic regression, support vector machine, neural network, decision tree, and random forest. Supervised learning algorithm types are to be divided into regression and classification. In case of regression, the objective is predicting the continuous output. So example, we can go like this: linear regression, polynomial regression, SVR, support vector regression, and decision tree regression. For classification, we can go for a predict a categorical data class label, logistic regression, decision tree, support vector machine, k nearest neighbors, and neural network. So steps we can go for supervised learning is data collection, gathered labeled data for training and testing, data pre-processing, handle missing values, normalize or scale data, encode categorical variables, model selection, choose an appropriate supervised learning algorithm, training, split data into training and validation of the test, train the model using training set, evaluation, access the model using performance metrics, regression, mean squared error, mean observed error. We can go with different kind of regression metrics. Next, classification, accuracy, precision, recall, F1 score, everything is there. And for testing, test the model on unseen data to evaluate generalization. Next is deployment, use the model for predictions in the real world application. These are the supervised learning, and here we can go for a very simple program with applied into the problem related to the house based rate prediction. The problem statement is predict the price of the house based on its size. Input feature here we are considered as house size in square feet. Output label is house price in dollars. So here we are going to analyze the data, and the data to be represented by visual points with the help of Python also. So here house size 500,000, so the value to be listed here, and the price also to be listed here. Steps in supervised learning for linear regression: define the input and output, identify the features and labels, choose a model. For this example, we use linear regression. Train the model using the training the model to fit the model parameters, test the model, evaluate the performance using test data, make prediction, predict the output for new inputs, and we can go with the visualization flow charts. For linear regression model, the model equation is m, slope of the line, c, we can have some intercept. Goal is minimize the error between the predicted and actual prices. So we can have the graph, we can easily plot the data points versus house size and price. So define the problem. First objective is predict the value of the house based on its size. Input feature house size in square feet. Output target label is house price in dollars. So the problem we can go like this. Here training set, we are going to divide the data into two things. Training set used to train the model 80% of data. Test set to used to evaluate the model 20% of data. So select the model based on the linear regression y, which is equal to mx plus c. Y predicted house price, x house size, it's about the feature, m slope of the line, weight, and we can go for the intercept. So this is to be evaluated by y, which is equal to mx plus c. So train the model, we are going, definitely we can go for a goal. So minimize the error between predicted and actual price. Here we have the loss function is there, MSC is there. So here y is actual price and yi we can go for predicted price, and n is a number of data points. We can also use for optimization, use gradient descent to adjust m and c in order to dealing with the parameters to minimize the MSE. Test the model. We can go with the mean absolute error MEE, and R squared score. R square score is also there. So make the prediction. Here the predictions to be calculated with the help of some values. So substituting the values, and we can easily get the predicted price. So this is the way we can work for a very simple linear regression model. So this will be very useful to predict the house price. So we can go for visualize the plots, and we can go for an improvised model also. For more number of features, we can go for polynomial regression for non-linear relationship. So this is the module progress. So here we are discussed about supervised learning with a simple example of linear regression. So this is the basic idea to enter into quantum machine learning. Thank you, learners.